Hello and welcome back. Here we go over some sample solutions for the functions we've discussed. So one of the exercises was to write a simple function to calculate the Fibonacci numbers. And this we can do in the following way. We define the function with the def keyword and call this function compute Fibonacci and give an argument n numbers for the number of Fibonacci numbers we want to calculate. So one of the ways we can implement this is to have a list. So we initialize the list with the first two Fibonacci numbers, 0 and 1, and then use a for loop with a range of 2, starting at 2, until the number we want to go to with a step size of 1. And then the new Fibonacci number would be to have the two preceding ones. So we can take the index I at this one and subtract 1 or subtract 2. And these are the two previous elements in the list that computes the new Fibonacci numbers, and we append this to the return list, and then finally we return the return list at the end of the function. Then when we call this function, we have here the list of the Fibonacci numbers that we call with the function, and for example we use 10 function. And then we can print the list, and these are the numbers we would expect. We were also looking at how we can use recursive function to do the same thing. So here is the first variant. We can define a function Fibonacci again and give it n as a parameter. Now with recursive functions, it's particularly important that we have defined stopping criteria. So first of all, we need to see that Fibonacci numbers are not defined if n is a negative number. So here we return none. To make sure that we have a defined value, none, when we have this illegal value. And then we need to define the stopping criteria. If n is smaller or equal to 1, then we return n. So if n is 0, we would return 0. If n is 1, we would return 1. And then else, and this is then the recursive part, we call this function again. Note that here and here the name is the same. And give it the argument n-1 and n-2. So this is a recursive definition, and we made sure that it says in stopping criteria. So if we do this then in a loop between 0 and 10, we can compute each number. So first we have 1, 1, and so on until we reach the last one here. The variant of this is to use a lambda function. This is very compact because we don't have to safeguard against negative numbers and so on. Depending on our use cases, this definition might be helpful, but we also might run into unexpected behaviors. Right, so here we can say Fibonacci is a lambda function of n, and we return n if n is smaller or equal than 1. Else, we return this construct, and it's the same name here again. So this calls it recursively. So we get the same results in a very compact way. And as you can see, this is very maybe efficient in writing, but it's quite hard to understand what's going on. The third way we want to implement this is the generator. The generator has the advantage that we don't have to sort of specify how many numbers we want to generate. When we write the function, we can just repeatedly call it. So this way, we would use the yield statement to define generator. So we have to initialize the first two values, x and y, and the first Fibonacci number, because the generator has the specific property that it sort of remembers its state. We need to initialize these properly. And then we just keep on looping in the sense that this is only executed one at a time when we call this function. We yield, this is the keyword for the generator, the fib, the Fibonacci number, and we've initialized it here. Then we compute the new one and update the values. And then we can just keep calling it. So each call would give a new one. Now we've, compared to above, we have made 1 for the whole. Python also allows to write multiple assignments on the same line. while during this assignment the value of the variables remain the same. This makes it slightly more efficient. So we can, for example, say x, y equals 0, 1. But so this is a slightly more efficient way of writing all of this, but you can already see that if we do this, it becomes a lot denser and maybe not as easy to understand.